Welcome ladies and gentlemen to Leet Logics. Today we'll be going to discuss the daily LeetCode challenge problem. So the today's problem is 316, that is remove duplicate characters. So what we have to do is that we are given a string as an input and we have to return the smallest string in lexical order such that it does not contain any duplicate letters. So when we first think, what does come in our mind? What we can do? We can use some data structure. So the data structure which we can use is definitely a stack. So let me explain the intuition how we'll do is. So we'll maintain two arrays, last index to track the last index of the character presence and scene to keep the track of the scene characters in the array in the string. Then we will use a stack st to store selected characters while maintaining lexicographical order. If we iterate through the string and each character current, if the current is already seen, that is scene of current is true, then we'll continue to the next character since we only want unique characters. While the stack is not empty, the current character is smaller than the character at the top of the stack, then what we'll do is that we'll show that means there is another occurrence of character ahead of I, that is current character. So we'll pop the characters of the stack and mark them as unseen. And we'll push the current character into the stack and mark it as seen. After processing all the characters, we build the result by appending the characters from the stack while reversing the order to ensure lexicographical smallest result. Let me explain you this through an example. Like we take the input s equal to CBA, CTC, BC. So first we have C. For C, current is C, which is not seen. The stack is empty, so we push C onto the stack and mark C as seen. Now the stack becomes C. Now we have to process B. Now current is B, which is not seen. The stack is not empty. B is smaller than C. We check if C appears later, which is true. Pop C from the stack. There is C is popped. We check C appear and mark B as seen and put B into the stack. Similarly for A is not seen, the stack is not empty, A is smaller than B, and B appears later. So what we do is that we remove B and add A. Then for C, we do the same for C, but this time there will be no C ahead of the currents. So that's why C is added. Similarly, D is added. Now this one C is not added, and in the last one B, there is no B after this last B, so that's why B is added. And after processing all the characters, the final stack will be ACBD. When we'll pop it, the order will be reversed. It will give us BDCA, so we have to reverse and return ACBD, ACD. So coming to the code, this is the code I was talking about. We keep an array of last index to store the last index of the character occurrence. Then we have a boolean scene array to just to keep the track that if the character has been seen or not. Then we'll iterate through the entire length of the string, and if we have seen, if seen, we skip the character because we'll get the character ahead, and pop the characters from the stack that are greater than the correct character while remaining the transition. Because we have to maintain the smallest lexicographical order, that's why we pop the uh, characters that are greater than the current characters. And if stack is empty and stack or not be, that is we are checking that greater, that the it is greater or not. Then we push the current character in the stack, mark the current character as seen as true, and rest is all like we are taking a string builder, we are popping the elements one by one from the stack and then returning the reverse of the result. So this was our result. Coming to the time complexity. So the time complexity is linear time complexity O of n, where n is the length of the string s. Coming to the space complexity, the space complexity is O of 1. No, actually, no. Yes, O of 1, because we have The array which we have are of fixed length, constant length. That's why we can say that O of 26, but it is equal to constant. That's why the space complexity here often. We also have a stack. So in the worst case, it can may have that all the characters are put in the stack. So it may have ON in the worst case. So thank you. Please like, subscribe my channel if you like the solution.